Hello, welcome to our last module, which is the non-parametric tests part 2. So we recall that non-parametric tests are used as alternatives to the parametric tests and not substitutes. They are used whenever the given does not satisfy the condition of a normal distribution. That is why non-parametric tests are for distribution-free populations. So part 2, topics included will be the mann-whitney U test and the Kruskal-Wallis or the H test. So for the mann-whitney U test, the other name for that is the Wilcoxon rank sum tests. So that it is a non-parametric alternative to the independent t-test, and such that this is used whenever two groups are independent and the assumptions or requirements of an independent t-test cannot be met, specifically the condition of normality. And this is the counterpart of the independent t-test, and that is why there is also an assumption that the given will be independent as well, even though the test of normality is not satisfied. And of course, it is called the Wilcoxon rank sum test because we will do the ranking later on, and then we will be, of course, getting the sum of those ranks. And again, since this is the counterpart of the independent t-test, this is also used to test significant differences between the means of two groups that are independent, and of course when the sample size is small. So for the mann-whitney U test, we're going to make use of the two formulas here for that the computed value of the U. And then here we are going to choose whichever between U sub 1 and U sub 2 have a smaller value, and that will be considered as the computed value of U. In n sub 1 and this is supposed to be n sub 2. So that's the sample sizes of the groups, and R sub 1 and R sub 2 are some of the ranks. And then the tabular value is determined by using only n sub 1 and n sub 2, and the mann-whitney U test will have its own critical value. This is for two-tailed testing. So for instance, your n sub 1 is 10, n sub 2 is 10. So go here, n sub 1 10 and n sub 2 10 at 0.05, so that the tabular value is 23. Or if n sub 1 is 7 and n sub 2 is 6, at 0.05, your value is 6. Or if n sub 1 is 13 and n sub 2 is also 13, then at 0.05, you will see it here, that's 45. That's how to use the table, as simple as that. So you are going to do the following steps if you're going to solve. So it is important that you do the ranking, because remember that this is used for smaller sample sizes, and we're going to make use of ordinal data. So we rank the observations from the smallest to the highest. We assign the rank. Pagsasama-samahin mo muna kapag nagra-rank ka, tapos ibabalik mo isa-isa doon sa, depende kung saang group na belong yon, and then you get the sum of the ranks, and then substitute in the formula and choose which of the U sub 1 or U sub 2 has the smaller value, and that is your UCV, or the computed value of the mann-whitney test. But of course, this is the only test of all the tests that we were able to discuss that will have a decision criterion, which is the opposite of the others. Here, we reject the null hypothesis if the computed value is less than or equal to the tabular value. Baliktad ito ngayon. Although there is another test known as the Wilcoxon some rank naman yun. Yung kabaliktaran nito, which is the alternative of the dependent t-test. Pero hindi na to, kasi hindi ko na isinama sa module na to. Kaya ito lang yung nag-iisang test na baliktad yung decision criterion. Again, we reject the null hypothesis if the computed value is less than or equal to the tabular value. So, we use this as our example. This has something to do with 18 patients who had advanced stage of leukemia, and then 10 were treated with the new serum and 8 were not. Uh, the survival time in years was reckoned from the time the experiment was conducted. Although yung example na to ay mukha siyang dependent t-test kasi may treatment at saka merong wala, so that dito hindi naman ginamit lang siya as example, pero independent ang treatment sa kanila. Medyo kulang lang yung tanong dito that it is supposed to be dapat ilalagay dito na not normal yung distribution na pinanggalingan nila. Okay. But anyway, this will be the example that we're going to use. So that from here, sabi lang naman dito, test whether the serum is effective rather. So that in our null hypothesis, we say that the serum is not effective, meaning to say that the mean of the treatment group is equal to the mean of the no treatment group. That is why the serum is not effective. But when we say that the serum is effective, therefore, the mean of the treatment group is not equal to the mean of the no treatment group. So, since the alpha is not given, so it is understood at 0.05, and we use a U-test because this is an example of a U-test. And the tabular value is 17. So, here, we have, sabi dito, 10 were treated with a new serum and 8 were not. So, 10 is N sub 1, 8 is N sub 2. Ito yon 10 at 0.05, 10, and 8. Ayan. So, 17. So, 10 and 8. Sometimes in some other books, ang sinasabi nila is that yung N sub 1 is the bigger of the two sample size. So, yun din ang isa pang condition nun. N sub 1 is the bigger of the two sample sizes. That is why N sub 1 is equal to 10 and N sub 2 is equal to 8. So, dito nang galing yan, 17. And then, N sub 1 is 10, N sub 2 is 8, 0.05 to the tabular value is here, 17. Kaya meron tayong 17 dito. And then, for this computation in number 5, we have to incorporate our Excel computations here. So that the first thing that we are going to do is, ito muna, itong lahat ng ito, yung 10 values na to, ilalagay mo dito, isa-isa. Isunod mo itong 8 values na to, idugtong mo dun sa 10, tapos isusort mo sa Excel lang naman. Sort from lowest to highest para maayos. And then, ganito na yung naging itsura ng arrangement natin. Ito na yung array of scores. So, this is just the chronological arrangement. Dito manggagaling ang ranking natin. 18 na sila. 10 plus 8 is 18. So, tapos, ito na yon. Titignan natin kung may magkakapareho dito ng mga values. So, number 5 and number 6 are the same. The values are 2. So, as with number 10 and number 11, so 3.1. The rest, wala namang pagkakapareho. So, kukopyahin na lang natin yung ranking na nandito. Like 2.9. Okay, so bakit 9? Hanapin mo dito. 2.99. Ayan, balik mo dito. Again, ang ranking, pagsasamahin mo silang lahat, pero kapag kukunin mo na yung sum of ranks, ihihiwalay mo na. Ihihiwalay mo na naaayon sa original problem. Okay, so that is according to the steps that we had made mention earlier. 3.1 is 10.5. Bakit 10.5? Because dalawa sila, number 10 at number 11, pareho yung value. So, 10 plus 11 divided by 2 is 10.5. We look for 5.3 and 5.3 is here, the last entry, so 18. 4.2 is here, 16. 4.5, 17, and then the rest. Tapos itong no treatment, 1.9 ang first entry. Hanapin natin ang 1.9, number 4. Ayan, number 4 siya. 0.5, number 1. Lagay natin number 1 and so on and so forth. Itong nakakulay pula, that is the sum of the ranks. So, balik natin dito. N sub 1, N sub 2, N sub 1, N sub 1 plus 1. Constant naman yung 2. Minus the sum of the rank, the R sub 1 or the sum of the ranks in the treatment group. And then, this is N sub 1, N sub 2, N sub 2, N sub 2 plus 1 divided by 2, sum of the ranks in the second column, which is the no treatment group. So that, if we're going to simplify, the answer is 5, answer is 75. Between 5 and 75, 5 is obviously less than 75. Then, the computed value, according to the rule, is that it is the smaller of the two values between u sub 2 and u sub 1, and that is 5. And 5 is less than 17, so we reject the null hypothesis according to the decision criterion. And since the null hypothesis is rejected, we copy that of the alternative hypothesis, and we can say that the theorem is effective, which means that the mean of the treatment group is not equal to the mean of the no treatment group. And that is how to do the hypothesis testing using the mann-whitney or simply the U test.